Before we move to the next section, we practice to understanding of the head loss. Head loss is a function of the v squared equal to g. Okay, if we apply to this problem, if we have 3 pi diameter in the, we call the pi in series, and pi 1 is diameter 1, pi 2 diameter 2, so and the flow is q. We can say that the q is equal because it's the same pi. And in this case, d1 compare d1, d2, and d3. So we can see that d1 is greater than d2 and d3. And for the area, okay, so area is A2 greater than A3. Okay. And for the next B2, V3, and B3. So in this case, Q is equal to V is equal to Q divided by area. So in this case, the inverse proportion. If this case for area 3 is a smaller area, so we expect that the velocity is V3 greater than V2 and greater than V1. And the next about the head loss 1, head loss 2, and head loss 3. Because we proved that head loss is a function of, so if we increase the head loss increase, so head loss 3 should be greater than head loss 2 and head loss 1. In this case, if we assume that the length of pi is equal, okay, we can draw the hydraulic gate line, energy gate line. For the hydraulic gate line for pi 1, pi 2, and pi 3. So we expect that the head loss head loss 3 is greater than head loss 2, head loss 1. Okay, this is a hydraulic gate line. You see that the slope of the hydraulic gate lines for the H3 is steep slope, and D1 is my slope. And if we add the velocity head in this velocity head, so the gap between the hydraulic gate line, energy gate line, and hydraulic gate line for D1 is smaller compared to the H3 is bigger. Gap between HGL and HGL. Okay. And next we move to the next topics about what is the Moody diagram for find the friction factor. In Moody diagram, we divide into 3 zones: zone 1, zone 2, and zone 3. Zone 1 is laminar flow, Reynolds number is less than 2000. And zone 3 we call the lap zone, we call the complete turbulence, where the curve becomes horizontal. Friction factor is a function of the roughness only. Okay, so this one we can say that it is this is the dividing zone. This part is the complete turbulence, so it means that the line is a horizontal line, and this zone is the laminar zone. Okay, and in between these two zones, we call the transition zone. Okay, transition zone to zone 2 is a friction factor is a function of the Reynolds number and relative roughness. Okay, in this case of laminar, the friction factor is a function of only the Reynolds number. So that is the three zone of the Moody diagram. Okay, and in different the same Moody diagram, but with a different shape. Okay, so basically divide three zone as well: laminar flow, transition zone, and complete turbulence zone. In between is we call the critical zone. And this one is for to estimate the relative roughness of the pipe. Is many depend on the different type of pipe. We can use the okay, this is called epsilon equal to roughness, relative roughness divided by roughness divided by diameter. Okay. Okay, how to use this Moody diagram and relative roughness. The next example is a commercial steel pipe. Show below has an inside diameter of 1 meter. Find the head loss. Assume the fully developed flow. Okay, in this case we can find velocity Q divided by area is 1.27 meter. Okay, and the next we can estimate the low number equal to velocity times d divided by nu. This is nu. Depend on temperature. Nu for 20 degrees Celsius is 10 power minus 6. This is a kinematic viscosity. Okay, so we can estimate the low number is equal to 1.3 10 power 6. And next we from equation of Moody diagram 10-4. Okay, we can the next for the commercial steel pipe we can estimate the relative roughness from above. This is commercial steel pipe. This line, the roughness, absolute roughness is 0.046, and we can read this from this. The diameter 1 centimeter, 100 centimeter, and we can draw the line from above to cut to this somewhere, and it's about okay, see 4.6 10 power 5. Either way you can use this number to divide it by diameter. Okay. Okay, we can use this. And once we know the roughness, relative roughness, and know the real number, we can find the friction factor for Moody diagram. Okay, you can find for Moody diagram. Use this is more clear. And this line start from this. a bit lower than 5, and we can something like this, make parallel to the 5, and then for the number is in the bottom is 1.3. Okay, and the matching the points. Okay. Somewhere here, and we can put this. Okay, that's what is. So we can read from this is equal to. Oh. Oh, the wrong one. That is not the correct point. The number should be somewhere 10 power 6. Okay, somewhere here. It's matching points here, so we can read this about 0.012. Okay, the friction factor is 0.012. Okay, and next we put in the equation, and we read that the friction factor is equal to 0.012, and we can estimate the head loss is equal to 7.4 meter